And we are live. I'm alone here. They call these kids. Where's the group? Now we are now live. Checking the audio. Put your thumbs up when you are here. Put your wait. I gotta put it on the chat. Put your thumbs up to show me. Yeah, put your thumbs up. Show me you're here. So far, I got one person. Whoever you are, put your thumbs up. I want to see who you are. Testing the mic. Check. I can hear myself. Video. Check. I can see myself. Put your Trevor. Welcome, Trevor. I don't know any Trevor from my class. Vix. Welcome, Vix. Triple thumbs up. Yeah. Welcome, guys. Let's just wait a few more minutes before we get started. But this is for preparation for paper 2. Okay, this is for paper 2. Welcome, Tips, whoever you are, Tips. This is to prepare you for your paper 2, which you'll be writing soon, tomorrow. I hope you're ready. You know, paper 2 tends to be much more challenging than paper 1. Gundo, welcome, Gundo, the true one. Gundo, welcome. Haley, Ditero, welcome. Ken Sani, I see you. Welcome. Yes, we are preparing for paper 2, which is tomorrow. As I was saying, it tends to be a little bit more challenging. But I believe in you. I think you will do much better on paper 2 than paper 1. Let's aim for that 100%. Let's aim for that increase. Now, I must tell you, I've seen the paper. Welcome, Kamo. Kamo, hello. I just saw it today. So you can ask me anything. Just don't ask me what's in the paper tomorrow. I can tell you that it goes against our school policy, ethics, and all of that jazz. But I can confirm some topics that are there and that are not. But I'm sure you know already what's in paper 2. Welcome, Pablo. Welcome, Nompumelelo. I see you there. Hi there. Welcome, Tireleto Letualo. Welcome. Yeah, as I was saying, I can just tell you there is only 3 topics in there. The first one is going to be analytical. The second one is going to be trig. And the third one, of course, Euclidean. And I think the easiest of the lot would be Euclidean. Sir is proving for Euclidean there. Only one question on proving. What do you mean proving? You mean like proving a theorem? Well, no, there's no proving of a theorem. It's one of those questions that are like, prove that these two lines are equal. Yeah, something like that. Welcome, Slindogutle. I see you, Slindogutle. But we'll try our best to prepare. And if you really grasp all these concepts that we're going to go through today, you should do well tomorrow, especially on trigonometry. Oh, there's a whole lot of trigonometry. My goodness. How long is the live? Well, I am planning to finish this under 2 hours, maybe an hour and a half. We should be done. There's a lot to get over. Let me just show you the paper I'm going to. Okay, first of all, let me switch to my phone here so I see your chats. Where's your group now? There it is. Let me join from this side. Great. I see you. Say which topics carries the most marks? Pablo, the trigonometry carries the most marks. Naturally, it always does. It always does. Examiners, they love trigonometry. Trig is like a favorite for examiners because there's a lot going on with trig, you know. Yeah. Okay, so here's what we're going to do. I am going to close that. Don't save that. And then I'm going to open that one and this one. So on my right, I have the paper, and on my left, that's where we're going to do the memorandum. Welcome, Lutendo. Welcome, Panache. Z, whoever you are, Z, welcome. Just to take you through the paper, we'll do some of this. This is analytical, so there's a whole lot of analytical as well. It has the second most marks, analytical. Then we've got trigonometry, all of this. And then we've got Euclidean. It's one of those that determine the angle, one of those. Then another one determine the angle as well. So that's all. That's all we got to do. Just 5 questions, and then we are done. If we go really fast, we can even finish within an hour, depending on how well you guys respond. So, like I was saying the other day, I would really like to make this as much interactive as possible. So please have a pen and paper, be writing and solving the answers as I solve them. And if you finish before me, pop the answer chat in the chat box and tell me what it is. That's if you solve these things quicker than I am. Okay, so like I said, the right is just for the questions. I'm just projecting the questions there. This time we'll be working on the left. If you want this document, I'll give you the one on the left. It has all the questions exactly like on the question paper. The only difference is this is where we're going to work out the memorandum together. So can we do more of analytical? Yes, of course. We are going to do more analytical. As you can see, I've got 2 questions. But the thing with analytical, there's just so many questions they can ask you. Like, look at this. Determine the gradient of PS. That's in question 1. Question 2 literally has the same question. Determine the gradient of AB. Um, they change the diagrams, but the concept's the same. It's going to be the same as well in your exam tomorrow, where question 1 and 2 have pretty much the same questions, and then you just got to learn how to use this principle. I said this bit to you in a class that in mathematics you will probably never see the questions that are going to come out in your test. You'll never know what's coming out. It'll be something new, guaranteed, something you've never seen before. You just got to learn how to use the principles. The things that don't change is the principles. Principles don't change, and that's what we really teach you. And but numbers do, scenarios do. Okay, we've gone 5 minutes in. Let's get started. All right, so I'm gonna write this side. Let's start inking. I'm gonna write what you should write. All right. Technology sometimes it baffles me how it disrespects the teachers. Okay, hopefully it writes now. I just got to make sure I don't press this little button here. Okay, question 1. Let's go. Question 1 says you got to read the statement. Do not attempt to answer the questions without reading the statements. Always read the statements. It says in the diagram below, straight line PS, where's PS? There it is. It's a straight line. It's defined by this equation there. And it cuts the x-axis at Q. All right, I see Q. MQR is a straight line. MQR, straight line. Okay, thank you. It meets at PR, which meets at PR at R, where the R at. There it is. N is given, is a point on PS. and Rn is drawn. Rn, I see Rn, okay. PQR is theta. Thank you very much. Okay, everything, all the clues are already there. Welcome, Pokamuso, I see you. Natasha Antini, I see you. Welcome, Petty, welcome. Welcome, guys. Let's get cracking. 1.1 says, determine the gradient of PS. So you got to go back to your graph because everything has already been put there. If it wasn't, I would have to put it myself. Now, I have to highlight where PS is. Where is PS? PS is there. So what you can do instead of highlighting so that your drawing looks weird, you can just redraw a little bit of the portion of the graph. So there's P there, and there is S. Okay, they want the gradient of PS. Now, in the middle, I need 2 points to determine the gradient, right? But in the middle, somewhere there, between P and S, I have Q, and Q is the coordinate 3 and 0. And then I have another coordinate there, S. No, N. And the coordinate of N is 6 and -2. These points are collinear, which means they're on the same straight line. I can use these 2 points to determine the gradient. The next thing you would need naturally is the formula of the gradient. Welcome, Dina. Dina Mweze. Okay, you need the formula of the gradient. Let me go black again. The formula of the gradient is a change in y, so that would be y2 minus y1 over x1, no, x2 minus x1. Now you can swap out the numbers, it doesn't matter. You can put letters instead of numbers. But what I'm going to do, I'm going to identify x1 as that, and then y1 is that. And then I'm going to say this is now going to be my x2 and y2. Please do this exercise. It will save you a whole lot of time trying to figure things out, because now I know just to look right there. Y2 is given by -2 minus y1 is 0 over x2 is 6 minus 3. If you have the answer already, pop it in there in the chat. Let's see what you got. Okay, let's bring out the calculator. There we go. So I've got a fraction, -2 minus 0. I'm going to put everything exactly as it is. Now, I know you can do it in your head, but please don't play with your marks like that. It's very, very easy to make a mistake. Okay, so I get -2 over 3. So this is now the gradient of PS. That's what they asked us for. Okay, asked and answered. Let's go now for 1.2. Did anybody get it? Vix got it. Vix got it first. Ramare got it. No. Ramare got it first. You see, the signs are very important. Please, guys, there is a huge difference between a -2 over 3 and a positive. They are worlds apart. So if you forget the sign, you lose the mark. So make sure you respect the sign. Make sure to respect the signs. Okay, next question says calculate the inclination angle of MR. Where is MR? Once again, ladies and gentlemen, please, if you're not going to highlight MR, just draw a little line to show you where M is and where R is. There's R. So I've got the coordinate of R, and it's 10 and 4. I don't have a coordinate of M, but I have a coordinate of Q. It's right there in the middle. There we go. And it is collinear with M and R, which means they share the same gradient. Okay, so that's the first thing. When it comes to the angle of inclination, it has to do with the angle, the true one. Well done, the true one. You got the answer right. You have to solve the gradient first. Okay, so let's go black again. To solve the gradient, change in x. So I'm going to identify that's going to be my x1, y1, x2, y2. Please try to do this exercise. Don't play with your marks like that. You need to be 100% sure. And doing this exercise, it helps a lot. Okay, so what's y2? I just read it off. I see a 4 under y2 minus y1 is 0 over x2 is 10 minus x1 is a 3. Now let's bring out the big boy of a calculator, which is going to help us a lot. We put a 4 minus 0, come downstairs, put 10 minus 3. Pop the answer in the chat if you got it. Anybody got it? Vix got 4 over 7. Let's see, you got 4 over 7, Vix. Very good. But we haven't answered the question yet. It wants the angle of inclination of MR. Now we know the angle of inclination is always coming from the horizontal plane to the line. So it's that angle there. And also we know that another formula for the gradient is tan the angle. So I'm gonna name this angle. What shall we name it? Let's name it angle small m, right? So we're gonna say small m is equals to 10. I mean the gradient is equals to 10 small m. Now I got two m's, but anyway, you get the point. Let's name it m1 rather. M1, right? M1. Let's call it M1 just to distinguish it. Now we got the gradient, which is 4 over 7 is equals to 10 M1. That's what we're looking for. Now to find M1 is just simply M1 is equals to the arctan. And then you put that 4 over 7. There we go. Bring out your calculator now. We're going to go shift 10. And then we're going to put 4 over 7. Go to the side ones, close it, and that's going to be equals to 29.74. Did they say anything about decimals? How many? No. So that's the angle of inclination there. You can write it in full. Who got it right? Ramare got it right. Slindoguhle, 4 over 7. Ooh, you're a little bit late, Slindoguhle. But you are correct as well. Okay, let's move on now to 1.3. It says now determine the value of theta. Now let's look at this real nice. This is now 1.3. Always start, if you're not going to highlight these things, just draw a little diagram for yourself, okay? It's like this. And I got P there, and I got S there. That's Q, okay? And I got M, and I got R. And I am looking, let me just draw a horizontal plane. There we go. So I am looking for this angle over here, theta. To get that angle, I'm going to need this big angle of PS, okay? And then I'm going to need this angle of MR. Subtract the two angles, and then I get what's in the middle. Subtract big and small. I'm going to get my answer. That's how we do it. So far, I have this green angle. That's what I solved here. And it is 29.74 degrees, this green one. Now I need to solve for this big one. Before I solve for that one, I'm going to need the gradient, right? Because the gradient is equals to 10, whatever angle. Let me call the red one red R. I'm going to call it R. This is angle R. I'm gonna call this green one that we've already solved. Doesn't matter. It's already green. You get the point. Now, what is the gradient of this line PS? I think we should have solved it right there at the beginning. It is negative 2 over 3 is equals to 10R. Now you can see that R there is actually an obtuse angle. To solve this one, there are two ways of doing it. There is the quadrant way, and then there is just put it in a calculator with its negative sign. I don't like that way. I like to say this negative sign is just telling us which quadrant it is from. Where is 10 negative? If we do the cast in grade 11, we do cast. It is negative here and also there. And then the second condition is that you have to know that the angle of inclination is always between 0 and 180. So then we are working with the second quadrant there. Okay, now when it comes to arc10, okay, this is just the reference angle we are solving when we do arc10. And the number you're going to put in the calculator is always going to be positive. You're never going to put negative numbers in there if you're using this method. You're never going to put negative numbers in there. So I'm going to show you this method and the other one. And then you bring out your calculator. I suggest you really learn this one this method, because you'll use it in metric as well. It will come in handy if you master it now. And then we got 2 over 3. You go to the side ones, you close that, and we get 33.69. Now you can see that the reference angle is actually an acute angle. To convert it to an obtuse angle, because as you can see, the red angle is an obtuse angle, right? So what we have to do is go to the second quadrant. We know that in the second quadrant, it's always 180 minus the reference angle. Okay, 180 minus the reference angle. So this time it's 180 minus 33.69. Put that in a calculator. 180 minus 33.69. And what do we get? We get that big number there. Convert it to a decimal, it's 146.31. So going back to our angle here, the red one is 146.31. Okay, so to get theta, then I have to subtract the two angles. All right, so then I'm going to say 146.31 minus 29 point, I forgot, it was 29 point what? It was 29.74. That's why I did that little diagram there to remind myself. Okay, 146.31 minus 29.74. And then I get a final answer of 116.57, as that's theta now. Okay, did anybody get it? 123.69 VIX. I don't know how you got that, but let's just confirm. Let's confirm your answers, please. Always make sure that you did everything right. Well, my method was correct. I don't know where you went wrong, Vix, but so far so good. I think we're okay. What else am I seeing here? Where are we? Okay, I think we can move on. That's the angle. Oh, the angle must have degrees. Okay, the angle must have degrees. Okay, nothing else there on the chat. So let's move on to 1.3. If there's no other problems, say please re-explain. I see my mistake. Vic says he sees his mistake. Nompumelelo, I encourage you to rewind this tape, this video. It's going to be available after we're done doing this live. It's being recorded basically. You'll have access. Oh, by the way, please like and subscribe to this channel. It comes in handy. Please do, as you know. We like it when you like and subscribe. Okay, but the whole thing, Nompumelelo, to solve for theta, you have to solve for the big triangle and subtract the smaller one to get the one in the middle. Okay, that's all it's about. But before you can do that, you need to solve the actual angles. Okay, oh, maybe I said I'll show you the second way, which I don't like. The second method to solve this number of 146 is that you can just say, go straight to R and say 10 arc 10. This time put the sign of 2/3. Okay, if you do this method, it will give you the straight answer. So let's try it. So we go shift. Oh, no, let me clear this first. We go shift 10 negative, it's negative 2/3. You go to the side, close it, and that's gonna be equals. It gives you a negative. Yeah, that's why I don't like this method. Just don't put that negative, because it will give you a negative 33, and then you still have to, this time you have to put, to solve the actual angle of R, you have to still say, because we're not looking for a negative answer. I mean, look at this red. It's definitely positive. You still have to say 180 minus that negative answer. I mean, it's the same answer. It's just like I said, I prefer you always put positive values inside this bracket, never negative. Look what happens when we put a negative one. That's exactly what I'm trying to avoid. So let's not do that. Let's always use positive answers. Okay, that's good. Titeboho says, thumbs up. Welcome, Titeboho. We are now in question number 2. Question 2. Let me write this down first. Let me just say question 2. Question 2. We'll start with 2.1. Okay, so it says ABC. Always read the statement. ABC is a parallelogram. Now, there are some properties of a parallelogram that you should know. For example, you got parallel lines that are equal. You got opposite sides that are equal. You got bisectors that are equal, But let's read. A is given as that point. Where's A? There it is. B is given, it's labeled. There it is. C is given, it's labeled. D is given, it's able. Okay, so tomorrow they will give you another shape. It's gonna be, it's not gonna be parallelogram, but one of the shapes. You should just learn the properties of those shapes, the common shapes. It's a parallelogram, a rhombus, a kite, and a rectangle or square. You should know those properties, because this type of question, even though they're asking you the same things to solve, but it's the properties that you have to know. Okay, so 2.1, calculate the length of BC. Okay, like I said, try to do a little diagram for yourself so that you can see where BC is. So there's B. Okay, so it's like this. I got C over there, and it is -1 and 10. And I got B over there, and it is 4 and 0. There we go. Now I like to put the values, the little subscripts. I'm going to make this one x1, y1. And then this one will be then x2, y2. Now, what's the formula for length? So I'm just going to say BC will be equals to the square root, open the brackets. Doesn't matter how you put it yet. I'm going to say x2 minus x1 squared plus y2 minus y1 squared. Okay. And then keep the square roots, don't change it. Now I'm doing the substitution. There's a mark for choosing the correct formula and a mark for correct substitution. Okay, nothing going on the chat. What's x2? You just read it off there as -1 minus x1 is 4. Close it, square, plus y2, you just read it off, it's 10 minus y1 is 0, square the whole thing. From here onwards, do not, I repeat, do not simplify this thing. Put it exactly as it is in your calculator. I assure you, your calculator can do this operation. Square this plus, open another bracket, it becomes 10 minus 0 squared. Okay, so I get a value of 5 square root of 5. That's it. And then since it's a length, it has to be units. They did not specify whether to leave it as a decimal or not, so I'm just gonna leave it as a third. It looks more cute as a third. It looks cuter this way. Nobody could get it. All right, let's move on. Determine the gradient of AB. Like I said, draw for yourself a little just construction there to show yourself where is the position of A and its coordinate -2 and -6. B and its coordinates, there is B, it is 4 and 0. Okay, there we go. Like I like doing, I'm going to name these. I'm going to call this one x1, y1, x2, y2. And then write down the formula of a gradient. The formula of a gradient is changing y. So that's y2 minus y1 over changing x, x2 minus x1. You can now do the operations. Come on, guys, put answers there. Put answers there. Okay, y2 is 0, just reading it off, minus y1 is -6, which is going to change. A negative and a negative makes a positive, so it's +6. And then x2 is 4 minus a y2, what am I doing? X2 is 4 minus x1. x1 is -2, and negative and a negative makes it positive, so that becomes +2. Okay, now I know you know how to do this one in your head, but please don't. I don't play with your marks like that, even if it looks easy. I don't trust you anymore. Just put this in a calculator. The things I've seen, my goodness. Just put it in a calculator, please. A person would have this, all would work out nicely, and then mess it up at the end. Because what did you do? You used your head, you were stressed under exam stress, not thinking straight, just stressed, when you could have just used calculator. Don't play with your marks like that. Very well done. Nutendo got it 1. Slindoguche got it 1. Well done, guys. Proud of you. Let's go for 2 where are we? 3 now. It says determine the equation of CD. Now, if you're not going to highlight it, as you know, just put draw for yourself there. Okay, I'm gonna draw it in blue. It's shaped like this. I've got C there with its coordinate, which is -1 and 10. And then I've got D there with its coordinate X and Y. Now, I don't have enough information to draw to come up. Well done, Z. You got one. Well done. The true one. The true one got one as well. Well done, guys. So I don't have enough information, which means now I have to rely on my knowledge of a parallelogram, the properties of a parallelogram. According to the parallelogram, as the word says, they got two lines that are parallel. And if two lines are parallel, that means they share the same gradient. So if I can get the gradient of the line AB, I can use it over here to solve for my line, because remember the equation of a line is given by y is equals to mx plus c. So to get that m, that's the gradient. Didn't we solve the gradient of AB? Oh, we did, just above, and we got it to be a positive 1. So the gradient here is 1, which means the gradient of DC is also 1. So I'm just going to substitute 1 where I have an m. Then it becomes y is equals to x plus c. You don't have to write a 1. You can just, it's imaginary or something. Can't we say the coordinates of D are 0? No, Pablo. We don't leave anything to assumption here. We need to solve it. If it's 0, then so be it. But we need to solve for it. Okay. Now, in order to complete the equation of this line, I need one more point that the line is passing, and that's going to be the point of C, where I have X and Y. That's the point C. What that means is that where I have, I'm just going to write it there, X and Y. Where I have an X, I'll substitute -1. And where I have a Y, I'll substitute 10. So there's a Y there, I'll substitute 10 is equals to, there's an X there, substitute a -1 plus C. We are trying to solve a C now so that we can complete the equation of the line. Nobody got it. So let's do mathematical gymnastics. If this one jumps and comes this side, it becomes positive. And then it becomes 10 plus 1, which is 11. So the value of C is 11. Now we can complete the equation. It's y is equals to m is 1, and then x, and then plus C, which is 11. There we go. Pablo, you got it right. Well done, sir. That is the correct answer. That's what we are looking for. Thank you very much. Okay, so we got the length, we got the gradient. Determine the equation of CD. What were we doing here? Yeah. We got it. Yeah. That's it. Okay, anything else this side? We all good? Okay, thanks guys. Okay, let's move on. CD. Determine the coordinates of M, the midpoint of BC. Let's move on. We are now on 2.4. And it says, now the midpoint of BD, we need the if you're not going to highlight it, just redraw it, please, to put things into perspective. I got B over there, and its coordinate is 4 and 0. And then I've got D over there, and its coordinate is X and Y. Okay, there we go. It's x and y. So if I look at this, I don't have enough information once again, because I'm looking for m. It's the midpoint, and to solve the midpoint, I need 2 points so that I can solve the midpoint. Remember, the formula for a midpoint is actually m. The midpoint is given by x1 plus x2 over 2, and then y1 plus y2 over 2. So I don't have enough information, which means now I need to rely on the knowledge of the properties of a parallelogram. Now, according to a parallelogram, the midpoint of CA is also the midpoint of BD. So let me just put CA. CA is like this. I've got C over there, and its coordinate is -1 and 10. I've got A down here, and its coordinate is -2 and -6. So if I can get this coordinate right here, then I can solve for the midpoint. All right. Okay, let's do that then. I've got all the information I need. Now I need to identify which one is x1. I'll call this one x1, y1. I'll call this one x2, y2. Now I just read off the midpoint then of BD is equals to x1. What's x1? Just read it off. It's -2 plus x2 is -1. All right, all over 2 always. Y1 is -6 plus what's y2? It's 10 all over 2. Now bring out your calculator. Okay, fraction -2. A positive and a negative gives me a negative, and then the number is 1. Come downstairs, put it 2. What's that equals to? So that's going to be equals to -3 over 2. And for the y, I've got a -6 plus 10. Okay. Ooh, I put 100. No, 10. Come downstairs, put it 2. That's equals to 2. So that's the midpoint. The midpoint is -3 over 2 and 2. Okay. Yep. Okay. Pablo says, oh, Vix got it right. Well done, Vix, whoever you are. Shout out to you. Pablo says, if we're dealing with a shape that doesn't have a midpoint, can we then say the coordinates of D are 0, 0? Hey, you love that 0, 0. Pablo, no, you cannot say that. You have to find another way to solve it. There is always going to be another way to solve it, and it's most likely going to be this way. But remember the properties of all the quadrilaterals. They pretty much almost all share the same midpoint because of their diagonal. So this is always going to be the case. Okay. All right, let's look at the next question. It says determine the coordinates of M, the midpoint, which is theta 1. We are now on 2.5. Hence or otherwise determine the values of X and Y. Okay, now that we know the midpoint and that they are sharing the midpoint, we know to get to the midpoint. Okay. Before we do that, ooh, I've almost forgot. We need D, which is X and Y, and then B, which is a 4 and 0. And then we got the midpoint there, which is what we just solved, negative. What did Vix get? 3 over 2 and positive 2. That's the point M, right? Cool. So here's what we got here. That's the clue. In order to solve for M, I'm going to name them once again. I'm going to call this one X1 and Y1, right? And then this one is going to be X2, Y2. I can just leave them as X and Y. That's cool. But for the purposes of this, I'm going to leave it like that. So how do we get negative 3 over 2 using these two coordinates? We actually say x1 plus x2 plus x2 over 2. That gave us negative 3 over 2, right? Because that's the value of x that we were looking for. X1 represented by 4 plus x2 represented by just x over 2 is equals to negative 3 over 2. Everything else stays the same. We just have to do mathematical gymnastics now to solve for x. First of all, we get rid of these two. We get rid of numbers by doing the reverse operations. Currently, what's happening to the x? It's being divided by 2 and 4 is being added to it. So to get rid of this division, we multiply by 2. And what we do on one side, we must also do on the other side. I'm taking you back now to grade 8, and we'll be left with 4 plus x on this side. These two will cancel, be left with minus 3. What's currently happening to the x right now? 4 is being added. To get rid of it, we do the reverse operation of adding, which is subtracting 4. What you do on one side, you do on the other. Okay, 4 minus 4 is 0. You don't have to write it. Please don't. Now you know what I'm going to say about this one. Put it in your calculator. Don't play with your marks like that. Don't use your head. Very easy to make a mistake. Minus 3. It is minus 7. So the value, well done, Vix. You got it all right. You got it correct. Okay, we'll do the same in solving for y. We're just going to go back here. Now, remember how we get the y value. We say y1 plus y2 over 2. And that should give us that value there of 2. Y1 is represented by 0. That's y1. And plus y2 is represented by just y. Over 2 is equals to 2. Now we got to do mathematical gymnastics. Multiply both sides by 2. What's the value of y? Let's put it there in the chat. Madome Ramare. Well done, buddy. You got the whole thing correct. The answer is y is equals to 4. So these are the values of x and y. We got it, guys. Oh, come on. Let's move on. Oh, that's the end of it. Okay, that's all you have to do with analytical. You're just solving for a bunch of lines, a bunch of angles. That's it. They can't ask you anything else. The only tricky part is by knowing the properties of the shape you're dealing with. So please go remind yourself the properties of all the quadrilaterals. Please, especially the diagonals. Okay, let's move now to trigonometry. For this type of question, can I use reverse midpoint? Yes, that's exactly what we did, Pablo. We reversed the midpoint. Okay, let's go for question 3 now. Question 3, let's write it down. Let's write question 3. Question 3. And it says in the diagram below, I'm given a point. First of all, notice this is on the third quadrant. And I'm given the point P, all right, is a point. OP is 17. Okay, there they wrote it. And a reflex angle of theta. Okay, that's cool. Before you answer this question, calculate the value of t. Just redraw yourself. If you're not going to use the drawing here and highlight and complete the drawing, just do it yourself. So first of all, I'm on the third quadrant, so my triangle is down here. To complete it, I do this and that, where that's 90 degrees. Theta is over here, reduced to there. 17 is the hypotenuse. Opposite theta. Okay, if you are not sure what to do there, just put P minus 8 and T, and then do this exercise that I always do, where you put a little x and a little y. So negative 8 is the value of x, which is over here. It's negative x, negative 8 from 0 to negative 8 there. And then the value of t is the y value, the y. Okay, so it's like it's right here. It's from there to there. That's t. Okay, so t is represented by y. Now, to solve for t, which is the y value, whenever you have the situation, a triangle which is a square, which is a right-hand triangle, you can use Pythagoras. Let's use Pythagoras. Pythagoras says x squared plus y squared is equals to, let's call this a radius or a hypotenuse squared. So what is x? X is negative 8, and then we square that. Plus, what is y? Y is t. Put it in a bracket, it's squared. And what's the value of r? R is 17. So you have everything you need to solve this. Then this becomes t squared is equals to 17 squared. Let me keep the brackets. This time you subtract minus 8 squared, just like that. And then to get the value of t, then you're going to put this whole thing under a square root. Square root both sides like that. Okay, so that's exactly what you're putting in your calculator. Square root of, open the bracket, put it exactly as it looks there. Don't think too much. Minus, open the bracket, negative 8, close it, and square it. And you get 15. 15. The value of t is 15. Okay, so when it gets to the signs, you can literally see that this t value is in the negative side. So therefore, you will conclude that t is actually negative 15. That means from there to down here, this is negative 15. From there to there, negative 8, as we spoke about it. Who got it right? Vix got it right. Plus or minus? Now, yes, you are certainly right, Pablo. Every time you use a square root, your answer is always going to be plus or minus 15. But for t, we are choosing the negative one. Why are we choosing the negative one? Because we're on the third quadrant, and we can see that t is on the negative side as well. Okay, so every time you square root, you're either going to choose a positive 15 or a negative 15. We choose the negative one because we can see the diagram. We can see that point P is on the negative side. So respect the signs. Okay, there's a huge difference between a positive 15 and a negative 15. So respect the signs. So that's how you solve for T. Let's continue. 3.1.2. Determine the value of each of the following without using a calculator. So because it's still 3.1, though it's 3.1.2, it means we must still use, it's still the same question from 3.1.1. So we will use the same diagram. So the first one is cos negative theta. First of all, we have to determine which quadrant is this one. Let me put my cast diagram here. This is the fourth quadrant because we're going negative. So when we go negative direction, we go clockwise. So we're on this quadrant, and cos is positive there. So we can rewrite this as cos theta. Once we have simplified it, we can now go back to the diagram and look what is cos theta. Now cos is given by, according to SOHCAHTOA, it's adjacent, and the adjacent is 8. Adjacent is 8 over the hypotenuse of 17. It's the third quadrant, so cos is definitely negative here. The hypotenuse is always positive. It's never ever going to be negative. So we just take the answer as negative 8 over 17. Now, if you don't put this negative there, again, there's a huge difference between a positive number and a negative one. It will make this entire answer wrong if you don't put the negative. So please respect the signs. Okay. Right, nothing on the chat. Let's move on to 3. Oh, this was A, right? So which means the next one is B. Okay, so for B, we are given 1 minus sine theta. So I'm just going to write 1 minus, nothing I can do with the number, but sine theta, I'm going to put it in a bracket. What's sine theta? According to SOHCAHTOA, sine is opposite. So the opposite was t, which we solved to be negative 15. There it is. So I'm just going to write negative 15. Okay, over 17. It's the hypotenuse. In the third quadrant, sine is negative, so negative 15 over 17. Very correct. Very correct. Now use your calculator, put it exactly as it looks. Open the bracket, put a negative 15 over 17. Close, don't close it yet. Go to the side first, and then close it. The final answer is 32 over 17. There we go. I forget to put equal signs sometimes. All right, anything on the chat? Nothing. So far, so good. Let's keep going. Let's go for C now. C, we are given cos 90 minus theta. Now, before we do this, we have to simplify it. Now, we know that this is the first quadrant. It's 90 minus theta. It's the first quadrant, and cos is positive there. And since this is a core ratio, this 90 changes a cos into a sine theta. So that's equals to sine theta. And what's sine theta? Go back to our diagram. According to SOHCAHTOA, sine is opposite of a hypotenuse. Opposite is -15. On the third quadrant, sine is -17. There we go. That's our final answer. Let's go for D. Any questions this side? No. Correct. Ramare. Correct. Now we've got D. D, we've got 10 squared theta. That's okay. This is like saying open a bracket, 10 theta, you close it and you square the whole thing. This is the same thing. It's just how it's written so that it looks cute. Okay, so let's go back to our diagram. Look for 10. According to SOHCAHTOA, 10 is opposite over adjacent. The opposite is -8. The adjacent is -15. Oh, hold up. The opposite is -15. So then I'll open my bracket, put -15, and the adjacent is -8. And then we square the whole thing. Negative and a negative makes it positive. So I'm not going to bother with that. I'll put 15 over 8. Go to the side ones, close the bracket, and square the whole thing. Okay, so then we get our final answer is 225 over 64. There we go. Thank you so much. Any questions? Very good, Ramare. You got it right. You are spot on. Okay, let's move on then to the next question. 3.2. 3.2 says if sine 17 is equals to A, without using a calculator, express the following in terms of A. Okay, so this one, what you have to remember about this one is this concept. Sine 17 is equals to A. There is always an imaginary one. It's either you multiply with 1 or you divide with 1. For the purposes of this one, we divide with 1 so that this then becomes the opposite over the adjacent. Now we need to complete a triangle. We need to draw a triangle on the side there. I'll draw a triangle right here. And let's say 17 is down here. Opposite is A over adjacent is 1. Now this side, it's always going to become 1 squared because 1 squared is the hypotenuse. So 1 squared is just 1. And we subtract the opposite sign because that's a right-hand angle. So this one is also squared. It becomes A squared. Okay, it becomes now our triangle is complete. We can answer the questions. The questions are 3.2.1. What is 1017? Well, we just look at our diagram. According to SOHCAHTOA, 10 is opposite, and the opposite of 17 is A over the adjacent, SOHCAHTOA. And the adjacent is the square root of 1 minus A squared. That's it. Let's move on to 3.2.2. What's happening in the chat? Oh, nothing much. We've got sine 107. Now we need to rewrite 107 in terms of 17 because we don't have that angle there. So we need to reduce it. And the reducing numbers are 180 and 360. Those are reduction numbers. So let's see, how can I get 107? If I say 180 minus 17, will I get 107? No, I won't. So if my reduction angles are not working, I can use corratios. If I say 90 plus 17, will I get 107? And indeed I do. So I'm going to rewrite 107 as 90 plus 17. Why did I do that? So that I can simplify. Okay, now 90 plus 17 is the second quadrant, and in the second quadrant sign is positive. And this is the correlation. It changes sign into cos, so this becomes cos 17. Okay, there we go. Then we can go back. Now we have the cos in terms of 17. I can go to my diagram, which has the angle of 17. Cos is adjacent over hypotenuse, and the adjacent is 1 minus a squared, and the hypotenuse is 1. You can leave it like this, or you can still simplify it further and just say, you know what, it's just 1 minus a squared. That's it. Okay, do we get marks for the triangle? Absolutely. There is absolutely a mark for completing your triangle. Yes, indeed. As you can see, 1017 was just 3 marks. The first mark was for creating the triangle, completing it. And then the second mark is just, there's nothing much going on here, the answer. This one is 2 marks, but there's a little bit more work done. Why is this one 4 marks? Anyway, let's see. Okay, 3.2.3 is cos 287. Okay, with our with our reduction formula. So reduction is 180. Let's start with 180. It's only 180 and 360. If I say 180 plus 17, will it give me 286? No. Okay, let's try 360. 360 minus 17, will it give me 2? No, it doesn't. Now I need to go to my core ratios. My core ratio is 90 and 270. Can use 270. If I say 270 plus 17, this is just one. I get 287. So I can rewrite 287 as 270 plus 17. Okay, the first question I ask myself, in this quadrant, 270, okay, so 270 is down here, plus 17, it brings me to this quadrant over here. And in this quadrant, cos is actually positive. Okay, remember cast, cos is positive, so this is just cos 17. Now that I've simplified it, what is cos 17? Who's this? Oh, sorry. Silindobuhle. Ngwenya. You got it right. Well done, girl. You go, girl. You are representing the ladies over here. The final answer will be the same one. 1a squared. Square root of 1a squared over 1. Yes, Silindobuhle. Well done, Slindo. You are fighting this year, Slindo. I admire your enthusiasm, your commitment to learning. Okay, let's go for 3.3 now. It says simplify fully without the use of a calculator. Okay, we can do that. Cos negative 225 sine 135 plus 330 all over 10 225. Okay, so just like we've been doing above, we kind of have to reduce these so that we know which quadrant we are working with. Let's look at negative 225. Which quadrant is that in? Negative 225. Okay, negative direction is this direction. So we would go like this. That's negative 90, negative 180, negative 225 is in this quadrant. And cos is negative there. Because it is, I mean, we can rewrite this. That then becomes negative 180 minus, ooh, I can hear the questions now. Sir, why is it a minus? It's just a direction. 45. Let's look at that if it gives us. If I say negative 180 minus 45, does that give me 225? Yes, it does. Okay. Pablo says, sir, for reduction, can I use that to get that? Yes, you can, Pablo. You can definitely do. We'll all get the same answer. All right, let's look at the next one, which is sine. I need to rewrite 135. What if I say 180 minus 45? Remember, 45 is also a special angle. Special angles are 180 minus 45 plus, what's this? Why is it just 330? Ah, I missed the sign. Let me wrap that. Let me wrap this too. Let's do the right thing. Here it should be sine 330. Now I need to rewrite 330 in terms of reduction formula, and it is 360 minus 30. Remember, special angles are 30, 45, and 60. 10 225 is always going to be 180 plus 45. There we go. Now we can do the reduction. We look at this in the bracket and we say, which quadrant is this? We've already dealt with this one. We said it is the second quadrant, and in the second quadrant, cos is negative. So we can rewrite this as negative cos 45. Which quadrant is this? 180 minus, okay, let me just have my cast. This is 180 positive going that way. This is the second quadrant. In the second quadrant, sine is positive, so this is just sine 45 plus, what quadrant is this? 360 minus 30 is this fourth quadrant. In this quadrant, sine is negative, so this is sine negative 30. This is all over. What quadrant is this? 180 plus 45, 180 plus 45. That's the third quadrant, and in that quadrant, 10 is positive. So this is just 1045. Okay, now we can reduce this. Now, if you do not know the answers, the special angles, just use your calculator. Just make sure you put the fraction part of it. So cos 45 is equals to square root of 2 over 2. The marks is for using fractions. It has to be fractions. You cannot use decimals. Otherwise, they will see that you actually didn't use a special triangle. This one is also square root of 2 over 2. A plus and a minus makes a minus, so this is going to be minus. What is sine 30? It's 1 over 2, 1 over 2, all over what's 1045? 1045, that should be just 1. Okay, so it's over 1. Okay, let me just write it. And then I'm going to put this thing in a calculator exactly as it is. I'm going to say square root of 2 over 2. Go to the side, say times square root of 2. It come down over 2. Go to the side, and then 1 over 2. That's equals to 0. So my final answer is just 0. That's it. That's it. Say, would the answer be -1? No, Romare, it's 0. Ayanda Mkwanazi says, say, can you also say 270 plus 60? No. For what? What was 270 plus 60? Oh, you mean for 330? Yeah, definitely. If I say 270 plus 60, yeah, you can, but you just have to remember to change this sign into cos, because now you have to change the sign to cos, and it becomes cos 60. Cos 60 and sine 60 and sine 30, they give you the same answer. Right. Say you forgot the negative. Where did I forget negative? Where did I forget? You know, it's very possible. It's very easy to make a mistake with these questions. I see what you mean. In my calculator. Okay, let's start again. Negative square root of 2 downstairs 2 times square root of 2 over 2 minus 1 over 2. Huge difference. A negative number and a positive one, they are worlds apart, and they make huge differences. There's a huge difference between 0 and -1. The correct answer here is -1, because I had forgotten a negative sign. And when you forget a negative sign, these things happen. Thank you so much, Pablo, for reminding us. That means Ramare was correct. You were correct, my man. Well done. Lutendo, correct. Vix, correct. That is fantastic, guys. That's fantastic. Let's keep going. We are doing very well. Where are we now? Which question was this one? This was 3.3. Let's go for 3.4. 3.4. 3.4, I got 1045 special angle 45 plus cos 180 minus x times sine 90 minus x all over sine x minus 360 times cos 90 minus x minus cos 180 minus x times cos negative x. Okay, there's a lot. 1045, let's simplify that. It's just 1. 1045 is just 1. Plus, what quadrant is this? Let's draw our Cartesian plane right here. Let's put cast. Okay, so it's 180 minus x. That's the second quadrant. In the second quadrant, cos is negative. So it becomes negative cos x. Take the variable, drop the number. Times, what quadrant is this? It's 90 minus x, the first quadrant. In the first quadrant, sign is positive, but because of this 90, it changes the sign into a cos x. There we go. What quadrant is this? X minus 360. So I go x minus 360 brings me to the first quadrant. In the first quadrant, sign is positive. So this is sign, drop the number, just take the variable. Sine x. What quadrant is this? This is 90 minus x. So I go 90 minus x. First quadrant. The first quadrant cos is positive. But this 90 changes a cos into a sine. So this just becomes sine x. And then I've got minus. What quadrant is this? 180 minus x is the second quadrant. In the second quadrant, cos is negative once again. So this becomes negative cos x. You always drop the number and just take the variable. What quadrant is this? Minus x is on the fourth quadrant. In the fourth quadrant, cos is positive. So this is just cos x. Okay, let's go for simplification now. This becomes 1 minus, okay, a minus and a positive makes a minus. Cos x times cos x becomes cos squared x. All over sine x times sine x becomes sine squared x. A negative and a negative gives me a positive. Cos x times cos x gives me cos x squared. Now I know what you're thinking. Oh, say, I can see the identities. Yes, you are right. This is the 1 minus cos is what we call the square identity, and this becomes sine squared x. Some of you are already asking me, where does this come from? Where does this come from? It comes from this identity over here. The identity is sine. It's what we call the square identity, plus cos squared x is equals to 1. So if I make sine x squared there, the subject of the formula, I just take the cos to the other side. It changes sign, it becomes minus. So it becomes 1 minus that. Should I write it? Yeah, let me write it. So sine squared x is equals to 1 minus cos squared x. So that's why we change the top into that. Okay, and the bottom, what is sine squared x plus cos squared? Oh, I can hear the bells ringing. It's 1. So my final answer then is just sine squared x. It's my final answer. Anything divided by 1 is itself. Say I want a merit for that. Good, you will get a merit. You deserve a merit. Okay, let's keep on going. Oh, this is an equal sign. It's not negative. It's an equal sign. Prove the identity. 3.5. These identity questions. I've got the left-hand side, and it has got cos x plus 1 in brackets, and then times cos x minus 1. Okay. This should be equals to minus 1 all over 10 squared x times cos squared x. So what I'll do is I'll simplify both sides. I do what I can and leave it where I can. So I'll take the left hand side and I'll multiply it out, right? So it's 1 over, I'm going to say cos x times cos x. That gives me cos squared x, right? And then cos x times negative 1, that gives me negative cos x. And then I'm going to say 1 times cos x, that gives me positive cos x. And then I'm going to say 1 times negative 1, so that gives me a negative 1. So this then simplifies to left hand side, gives me 1 over cos squared x. These two cancel each other. Cos x minus cos x is 0. I don't have to write to 0, so minus 1. Now I'm going to stop there. I want to look at the right hand side now. Okay. On the right hand side, I have 1 over 10 squared s. This is the quotient rule. So I'm going to change 10 into sine squared x over cos squared x times cos squared x. Okay. And then what I'll do then is we'll cancel these two. They cancel. And then I'm left with 1 over, oh, it's negative. Don't forget the sign. Hey, these signs, man, I tell you what, we need to pay attention. Okay, this is where I end. Now, if you look at these two, currently they don't look the same. But if you look at this, okay, if you look at that, it looks like the square rule, square identity. The only difference is this time instead of, because remember what we did up here, we said it's 1 minus cos squared x, but now I got the opposite, cos squared x, which means I can manipulate it. If I introduce a negative and multiply everything by negative 1, multiply everything by negative 1, this is just to manipulate, then it becomes negative 1 times 1 is negative 1. Negative 1 times cos squared x is negative cos squared x. Negative 1 times negative 1 is a positive 1. Okay, now watch this. A negative 1 stays a negative 1 on top. Let me just leave it like that. Now this is the square identity looking like itself now, and it changes to sine squared x. So both of them look exactly the same. Therefore, the left-hand side is equals to the right-hand side. That's how we prove the identity. Both of them give us the same answer. Now, there are many ways of doing it, but is my preferred way. Pablo says, sir, isn't the first sign on the denominator a negative? No, no, no. It's what we did right here is very correct. Now I know these signs we've been having a little bit of a challenge with them, but this time we got it right. Sir, Matome says, sir, is it okay if I make the right hand side equals to the left? It's very okay. Very okay. Vic says, Sir, may you please elaborate why you have to manipulate by -1? Well, the reason I multiply by -1 is just to manipulate the equation. But what I do on one side, I must do on the other side. I must multiply. The trick here is to multiply everything with a -1. That's why I multiplied every single thing. It wouldn't have been enough to just multiply the top, but it is acceptable to multiply every single thing just so that I can manipulate it so that it looks like the right hand side. Um, that's the only reason we did that. Okay. Any other issues here? Doesn't look like it. Okay, let's move on. Oh, Petty says, say, I think Pablo is talking about 3.4. Oh, Pablo, we are gone. 3.4, we are gone from there. I don't even know what did you mean? Say, isn't the first sign on the denominator a negative? The first sign on the denominator a negative. Well, I tell you what, Pablo, that's very. Let's check it out. 3.4. No, it's not negative. It's definitely positive. Remember your directions, Pablo. A positive direction goes anti-clockwise. So I went anti-clockwise X. I landed on the first quadrant. Then a negative direction is clockwise. So I go clockwise from there where I stopped. I must go -360. So I went negative this way, 360. It brought me exactly where I started. And where I started is the first quadrant. That's why it is positive. It cannot be negative. Thank you, Petty. You got it. You figured it out what he was talking about. I did not. Okay, the last question says, determine the general solution of, this is now 3.6, to sine x times cos x is equals to cos x. We have to do a little bit of gymnastics here. I'm just going to take this cos to this side so that it becomes 2 sine x times cos x minus cos x, that's equals to 0. Why did I do that? So that I can factorize. Okay, I need to take out the common factor. And the common factor here is cos x. You see it? So I have cos x. Open the brackets. To complete this expression, I must multiply cos x with 2 sine x. And then I have a negative. To complete this cos x expression, I need to multiply cos x with a 1. So that's equals to 0. And then I need to solve for x. So this just becomes cos x is equals to 0. Or I'm equating this part. Or 2 sine x minus 1 is equals to 0. Hey, looks like I ran out of page. So here's what I'm gonna do. I'm gonna do that. No, need to create more pages. Insert page break. It's taking the whole thing. I'm gonna have to fix this later. But basically, let's start up here. Let's make this 3.6 now. Wait. need to fetch it. I need to take all of this, or I can just take cos x is equals to 0 and then okay. So let's say 3.6 continued. 3.6 continued. So I had cos x is equals to 0 or 2 sine x minus 1 is equals to 0. Both sides have to be equals to 0. Pablo says, oh, I see my mistake. Thank you, Sir Petty. Okay, so now we can do to solve for x, you say cos, cos, put 0 in your equation, and then you get x is equals to, it's probably 1. But let's see. Shift cos, I'll put in a 0, close it. 90. Okay, it's 90 degrees. Or the other one was 2 sine x minus 1 is equals to 0. Do a bit of gymnastics, take the one this side, and then it becomes 2 sine x is equals to 1. Divide both sides by 2, and then it becomes sine x is equals to a half. Now, remember I told you in grade 11 we're dealing with quadrants. Where is the sign positive? It's positive in this quadrant and also cast and also the second quadrant. Okay, so those are the quadrants. What I'm going to solve for here is not x, but the reference angle, which is going to be sine a half. It's always going to be positive. Let's put this in a calculator. Sine a half is 0.5. Sorry, my bad. See what happens when I try to cheat. So it's 1/2. Put it exactly as it looks as you wrote it. We get 30. Now this is the reference angle. Okay, this is the reference angle. It's not the final answer. To get your final answer, you have to deal with the first quadrant and the second quadrant. Okay, let's start with the first quadrant. In the first quadrant, x is just equals to the reference, which is 30. And then you must say plus k 360. Okay, and in the second quadrant, x is therefore equals to 180 minus the reference angle, which is 30, plus k 360. What's 180 minus 30? 180 minus 30 is 150. So there we go, plus k 360. These are then your final solutions. 1, 2. We have to go complete this other one here. It was x is equals to 90 plus k 360. Okay, so you've got 3 solutions. That's why it's 5 marks. Any questions? Pablo, you good? Petty, you good? Vix, you good? Ramara, you good? Vix says, how do you identify when to use reference angles? You are always going to use reference angles. In grade 11, we introduced reference angles. As a matter of fact, what you were solving in grade 10, those were reference angles, because to get the actual angles, you have to check which quadrants you are working with. Okay. So 0, I mean, the reason we didn't use, I mean, 0 is kind of like the first quadrant. So, and it's also, I mean, I don't know how to explain it, but there's a graph, the cos graph. Remember, the cos graph looks like this, where it is 0 there. And it's 90 there, and it's 270 there, and what am I doing? It's 180 there. So cos of 0 is 1, cos of 90 is 0, cos of 180 is -1, cos of 270 is 0, and then cos of 360 is, that's if you are dealing with the actual points, the Cartesian points there. They only have one solution. Okay, but if you are inside the quadrant, then this one is 180 minus the reference. This one is 180 plus the reference. This one is 360 minus the reference. And then this first one is just the reference. That's how it's done. So you always solve references first, except if you have these special angles like 0, 90, 180, and 270, then you only have one answer. Cool. Was that the last of trig? Yes, it was. That was a lot. That was a lot. I'm tired. So, sir, this is for 5 marks. Absolutely. Kamohelo. Petty says, is it a provincial paper? No, it's not. The provincial paper, no, it's not. Say you forgot the cares. Where did I forget? Ah, yes, yes, yes. Thank you, Pablo. You see, you deserve a merit. As soon as you write K, you must always define K that it is an element of an integer. Okay, so K is an element of an integer. That's the sign of an integer. K is an element of an integer. Cool. All right, guys, I got a challenge for you. We can actually do these questions in 10 minutes. Euclidean, 10 minutes, we are done. Okay, let's go then. Question 4. In the diagram, O is the center of the circle. So if I've got a center, I see you should always, like I said in your class, you should always kind of take a pencil or something just to complete it. So if O is the center, that means I've got a radius here on OB. So that equals to OC, that's a radius, OD. These are radii, they're all equal. You kind of have to mark your clues as you read the statement. And then it says point O. And also, if this is a straight line, it's a diameter. Radius and radius is a straight line. But hold on, let's not go there yet. We're just marking radii for now. We can't assume this is a straight line, even though it looks like. Then it says points A, B, C, and D lie on the circumference. So, okay, I see they're on the circumference. And all points from the center to the circumference are called a radii. BOD is a diameter. Oh, BOD is a diameter. If that's a diameter, remember a diameter always subtends a right angle over there. So that's a right angle, subtends a right angle. So probably to solve for A2, I must say 90 minus 51, but let me not get ahead of myself. Let's go for AC and BD intersect at E. Okay. And then the angle A1 is 51, it's shown. B1 is 29, it's shown. Okay, now I've got all the information I need. First question, we got 10 minutes left. The invigilator just told us you have 10 minutes left. So what do? I'm going to say, okay, 4.101 with the cap is going to be equals to, if you can see it, no, nothing on the chat. If you can see it, it's actually 2 times the angle of A1. Okay, and we call this, every time you write a statement, the first time you must give a reason. Reason is angle at center is equals to 2 times the angle at circumference. Okay, so it's equals to 2 times A1. I can substitute it, is equals to 51. 2 times 51. Don't use your head now. Don't play with your marks like that. Use a calculator, please. Don't want to see mistakes. 102 degrees. 4.2, rushing against time. It says it wants A2. Oh, there we go. A2, I already know with the cap is equals to 90 minus A1. And what's the reason? Angle subtended, or let me say diameter subtends 90 degrees. Okay, so 90 minus A1. What's A1? It's 51. Don't use your head now. Don't play with your marks like that. Use a calculator. 90 minus 51. There we go. 39. We've got 10 minutes left, guys. 10 minutes left. Don't forget to put degrees. Next question. 4.3. I'm looking for the angle of D. Angle of D. What I got? So I've got a triangle here. I'm working with triangle DAB. If I look at triangle DAB, I've got everything I need, right? I can say, as a matter of fact, I can say the angle of D plus the angle of A, all of it, plus the angle of B, 1 is equals to 180. So the reason, sum of angles in a triangle. There we go. So what's D? That's what I'm looking for. I'm looking for the D plus angle A. The whole of it is 90 plus angle B1 is 29 is equals to 180. So to solve for the D, we say 180 minus, that's an 8. 90 minus 29. Use your calculator. Well, you have no choice with this one. Cannot guess it. 90 minus 29. We get 61. How many minutes left on the clock? We had 10 minutes. Now I'm sure we left with like 9.5. Let's keep going. The last question, which is 4.4, is the angle AC. Oh, anything this side? Pablo, well done. You got it, buddy. Okay, ACO. ACO. Okay, how we gonna solve? Okay, first of all, we know the angle O1. We solved O1 to be, we solved O1 here, 102. So we've got an isosceles triangle there, and then uh, equal angles, opposite sides, equal angles, type of thing. So let's go. How I'm going to write it is going to be interesting. Because of time, this is how I'm going to do it. I'm going to say ACO is equals to, first of all, 180 minus O1. That's a Q. Because of time, I'm making mistakes. Instead of O, I'm writing Q's. That's what the exam stress does to a person. It's O1 divided by 2. And then my reason will be, I'm just going to say sum of angles in a triangle. Sum of angles in a triangle. Okay, and then I'm going to substitute what's O1, it's 102 over 2. I'm dividing by 2 because it's, C2 and this other angle here, B2, are the same. Let's put that in a calculator. Start there. Put a fraction, 180 minus 102. Come downstairs, put in a 2. Hold on. What I'm solving for here is not the actual truth. 39. What I'm solving for here is actually not ACO. Where's ACO? ACO. What I'm solving for is C2. Okay, so please let's just cancel this one and let's put it as C2. C2. Did anyone spot that? Can I please explain? Can I please explain? 61. Where are we, guys? I'm on ACO. Can I please explain the theorem about diameter subtending? I'm not so sure we got enough time to explain that, Vix. But it's just a theorem, and the theorem states that whenever you have a diameter, the angle that's the diameter subtends is always 90 degrees. Okay, so anyway, I got C2, which is also equals to B2. Why did I solve for B2? Is because if I take out the triangle, let me just show it to you. If I take out the triangle CAB, you can see B1 is split into 2 and it's 29. It's split into B1 and B2. This is 29. And this one, we just solved it now to be 39. Okay. And also this one, C2, we just solved it to be 39. We are really looking for C1 now so that we can complete. Oh, no, actually we don't need C1. Nor do we need C2. But anyway, there we go. So we are looking at this triangle. Let me actually delete these lines. No, we need that second. Let me delete this one. Okay, so this one is split into 2. So therefore, if I use a sum of angles, remember I'm looking for ACO. Actually, let's put it back. That's C2, which is 39. We are looking for C1. If I do some of the angles in a triangle, add all of these ones up, they should give me 180. Okay, so let me just write it. C1 plus 39 plus 39 plus 29. I'm moving in an anti-clockwise direction. Plus 51. This should be 180. Why is this? Sum of angles in a triangle. In a triangle. Okay. So to get C1 then, or ACO, whichever one you use, let's say C1, which is actually ACO. Bring out your calculator, and then you're going to say 180. Subtract all these numbers. 39, mathematical gymnastics, 39 minus 29 minus 51, which is 22. ACO is equals to 22 degrees. That's the correct answer. Sir, can you use another method to solve the angle ACO? Of course, there are many methods to solve these things. As long as it makes sense and you get the correct answer, you can use any method you like. But these ones that got ACO 61, no, that's incorrect. It's not 61. As you can see, it's 22. Just try to follow what I was doing here. It makes sense. I don't know how you got 61, but yeah, no. You said it's because of angles opposite equal side. No. If you look at this diagram, ACO, you can't assume that CA and AB are equal. They are not. It's only OB and OC that are equal. But AC is not equals to AB. So you can't use that logic. Right. Hold up. I see what you did. No, it doesn't make sense. They're not. Your reason doesn't. Say, can you use another method? Yes, you can use another method if you want. I mean, as long as you get the same answer, I'm cool with it. So let me use another method. Fine, I'll show you another method. Another method to solve for C1. You're still going to say, okay, let's start here. You're going to say the angle D is equals to the angle C, the whole of angle C, which is C1 plus C2. And the reason is because I'm in same segment, and the segment is AB. So we got D to be 61, right? So C1 plus C2 is 61. Okay, so let me write that. C1 plus C2 is equals to 61. But we solved C2, and C2 was 39. We're still going to have to do this step. C2 is 39 plus C1, which is equals to 61. Therefore, C1 is equals to 61 minus 39. Still get the same answer. What's 61 minus 39? 22. The same answer is 20. Okay, so now these are, two methods of getting the same answer. So you could have used the top one or the bottom one. A, C, O is what they asked for. There we go. Say, how many marks do you get for stating the reason? 1 mark. There's always a mark for the statement and a mark for the reason. So if you do not write the reason, you lose marks. Okay, this one was a bit long for 2 marks. Well, that's it. I'm stopping right there. I know there's question 5. You are on your own here, but just looking at it, let's look at it quickly. This was the last question. There's X over there. And the question says, name with reasons 4 other angles equals to X. I'm going to leave this one to you. But read the statement. Try to find the other angles. You're probably going to use the 10 chord theorem to figure it out. There's also, okay, let me just do it quickly. This X, there's a tangent here. They tell us QR is a tangent. It's a common tangent for both circles. So, and then AD is parallel BC. So there's AD is parallel BC. Okay, let's just to highlight it more. And then they say find others that are equals to this X. So if I look at this triangle over here, ADP, if I look at ADP, running out of time, so things are looking ugly. And then I have a tangent here. Doesn't even look like a tangent. Let's try again. Actually, let's highlight it. Here's my tangent. So the first one says the angle between the tangent and the chord is what we call a 10 chord theorem. The angle between a tangent and a chord is equals to the angle opposite that chord. So I can say C technology. Actually, let me write it this side. I shouldn't write the answers here. 5.1. 5.1. So I can say really P1 is equals to X, and that's because of the 10 chord theorem. Okay, which other one is equals to X? So that's the 10 chord theorem. Thank you so much. What a mess. So I'm just gonna rub these things. Okay, what else? I can see, can we do it? It is a challenge. Yeah, we're doing it. I can see I've got 2 parallel lines here. Oh, come on. I want to highlight my parallel lines. There they are. And this one. And then I got a line separating the 2 parallel lines over there. So if I look at it, I can say C2 is also equals to C2 is equals to X, and the reason is alternate angles. Because of the parallel lines, you have to mention the parallel lines, and you have to mention them the way they gave in the statements, where AD is parallel BC. Okay, so that's the second one. Let's wrap these clues. We need another one. Okay, now if you look closely here, you can see that P1 is formed of this line and that line there. There's these two lines form P1 here. So P1 is also equals to P5 because they're vertically opposite. So then we can say P5 is also equals to X because they are vertically opposite with P1. Right. Okay, so we've got 3. That's how you do these questions. Okay, and then another one, we can look at this angle X that is given. Where does it come from? It comes from this chord here, DP. DP, as you can see, it's there. Which other angle does DP subtend in this big circle? It subtends E. So then we can say E is also equals to X, and the reason is because same segment. Woo wee. Okay, where were we? C2. Okay, that's that. How many did they want? They wanted 4. Oh, right, we got 4. Guys, we are done. This is the end of the paper. There is no more questions. Let me see the chat. Oh, that was it. All right. Let us stop the sharing and then we're finished, guys. We're finished. That's it. There's no more. The exam is over. We spent our 2 hours and we are done with this paper. Thank you so much for tuning in. All the best for tomorrow. Good luck. I believe in you. You can do better in this paper. Actually, paper 2 seems to be much easier than paper 1 in terms of topics and stuff, but that all depends on you. We're gonna see when we start marking what you guys get. Otherwise, thanks. Please like and subscribe on our channel. We need the numbers. So thank you so much. Like and subscribe. Goodbye. Thank you so much. Come on, hello.